Sisters here to talk about simplifying rational expressions. We're going to start this section with something short that we have already done actually in our look at exponential uh, expressions. We looked at the rules for simplifying these kinds of things already. So we're just reviewing that and putting it together and making the connection that these exponent laws apply to these rational expressions that we're studying in this unit. So these are what the questions are going to look like. It's going to ask us to state the excluded values. We've been doing that the last few days. So remember, in a monomial expression, you're looking in the denominator. You've got multiple variables. Each of those cannot equal 0. So x cannot equal 0, y cannot equal 0. Those would be our excluded values. The part that I want to focus in on today is simplifying the expression. So this expression has three pieces that we're going to have to simplify. We have a set of coefficients here that we're going to try and reduce, like a fraction. We have two x terms, so we're going to have to subtract their exponents to simplify, and two y terms that we're going to have to subtract exponents to simplify. So let's go through and do that together. We're going to go ahead and begin by looking at those coefficients. So the coefficients are 32 in the numerator and 4 in the denominator. We're going to consider that as a fraction. I'm just trying to reduce that fraction. So 32 over 4, both of those are divisible by 4 and reduces to 8, or 8 over 1. So that's the first piece that we're looking at. It's just looking at that fraction, coefficient, and reducing. I said the second thing we were going to do is look at the x's and see if we can't simplify that expression, that piece, and then look at the y's and simplify those as well. So for the x's and the y's, and when you have a term in the numerator and a term in the denominator with a like base, remember our rule, our exponent law says that we can subtract the exponents to simplify. So if we have x to the 5th over x, this x has an invisible one here as its exponent. So we're going to look at x to the 5 minus 1 power, or x to the 4th. For the y's, we have y to the 2nd divided by y to the 7th. So that would be y to the 2 minus 7, or y to the negative 5th. Now we need to put all three of these pieces together to write our final answer. So we know that the 8 is going to be in the numerator because it is a whole number, and so that goes in the numerator. X to the 4th will also be in the numerator because its exponent is positive. But y to the negative 5th, because that's a negative, remember that means we have to have our y to the 5th be in the denominator with a positive exponent. So our final answer will look like x to the 4th times 8 in the numerator, and then y to the 5th in the denominator. And then don't forget to list your conditions, right? Your excluded values. This is only true if x is not equal to 0 and if y is not equal to 0. So let me add that here. I want to make sure. There we go. X cannot be 0 and y cannot be 0. So those are our two conditions, our excluded values, and otherwise those two expressions are equal, assuming that x and y are not equal to 0. Let's do one more together. Again, we're going to state excluded values and simplify. So we've got 60 over 18 is our coefficient that we're going to try and reduce. 60 over the 18. Then we're going to look at the exponents on the a's and simplify those, and see if we can simplify the exponents on the b's. Now I made this one very similar to the previous example, so we're going to see those same components, those same pieces. So 60 over 18, those are both divisible by 6, so taking out the common 6, 10 over 3. Here we have an invisible 1 in our denominator as our exponent on the a. So again, we're going to subtract the numerator exponent minus the denominator. So 3 minus 1. And then here for the b's, it'll be 2 minus 3. So we get a squared, and that'll be in the numerator because it has a positive exponent. And then b to the negative 1 power. So we should be thinking that we're going to move this b term to the denominator because of the negative exponent. So in the numerator, I have a 10 and an a squared. And then in the denominator here, I had a 3. And next to that, I'll write the b. So final expression will look like that. 10a squared over 3b. And again, we should remember to put our excluded values next to it. So a cannot equal 0 and b cannot equal 0 will be the two pieces that we'll add here. So cannot equal 0 and b cannot equal 0. So there it is. That's our final answer. All of our components are listed there. And whoops, whoa, I can't draw a circle. Let's try that again. There we go. That's a little better anyway. So there's our conditions listed next to our simplified expression. So that's what we're focusing in on here. Day 2 with this. So give them a try, submit some work, and I would love to give you guys some feedback. Hope you have a great day.